So hello and welcome to another video after a long time. So today we're going to be doing May-June 2025 of computer science. This is again paper for practical. We're going to be doing the paper in Python entirely. So if you have any other programming languages like Java or Visual Basic in mind, do let me know via email or the comments, and I'll try my best to put out a video of that as well. Alright, so this is going to be the variant 4.1. 4.2, I hope to solve it pretty soon, so maybe in the near future, maybe in the upcoming weeks. Alright, so in this year, you have been given apparently 7 text files that you need to use in order to go ahead and solve the paper. And so we're going to be starting with question 1. I think you need the 7 text files for question 2. Alright, so let's go ahead and get started. Okay. So question number 1 says a program stores positive integers in a circular queue. Now remember that a regular queue, you just have a head and a tail pointer, and then you just keep pushing things to the tail and keep popping things out of the head. But in a circular queue, that means once you have filled up the queue to one end, the head pointer circles back to the previous position, or like the starting position, and then keeps on adding stuff to it as well. So it's like a circle. So there is technically loss of data in this queue. That means you're replacing it. Now you might change the program in order to kind of give it certain conditions, like a warning message or something that you're overwriting data or something. But generally, the logic of a circular queue is you're going to be overwriting data. That means just kind of restarting the head pointer itself. So technically, unless you are constraining it with something, your queue is never going to run out of space. But in this case, the question I think mentions that we gotta use 20 integers, okay? The queue is stored in a global 1D array of 20 integers with the identifier q. Each index is initialized with the data -1. That's the initial conditions. And we've got 3 global variables, with 1 being number items. I think this is used to keep track of how many stuff there are in the queue, even though it's like, a circular one. And then if you exceed 20, it's just going to go ahead and tell you that, okay, that's it, that's the limit you've reached it, even though the queue is circular. But again, the question varies, but the general logic of circular queue is you just kind of restart again. Okay, so that's why we use a circular queue. So without any further ado, let's go ahead and open the source file in in Visual Basic. Okay, so we've got all the text files over here. Okay, so now I'm just going to create a new file naming question1 underscore j25 dot py. Okay. Okay. So we're just going to close out the welcome screen. Okay. So we're going to be following the question now. So it says the write a program could declare an initialized queue, head pointer, tail pointer, and number items. So the queue is a global one-dimensional array of 20 integers with the identifier q. So there are many ways to do it. You can constrain it to just 20, or you could make it like unlimited. But when you're making it unlimited, uh, it's generally up to you that how would you want to make your queue. Okay, so in this case, we're going to be doing queue for 20 items. Okay, so we're going to be doing 20 items. So you could use a third bracket, or you could just say -1 for I in range, and you're going to be doing 20. So this kind of puts it to 20 into it. But since we're making a circular queue with a condition, I'm going to close, what do you call it, Copilot over here. So with the condition that you're going to be already having a number items counter, I think I'm going to skip on this. And instead, if you're in a Cambridge exam setting, you should mention that the size is going to be 20. Okay, you could do it in pseudocode style, or you could just go ahead and put in the size just like that. But it's important that you use comments in this case. Next, we're going to be doing head pointer. So head pointer is going to be equal to -1. Tail pointer is also equal to -1. And number items is equal to 0. Now, for this queue, what I would actually want to do is you have everything that is initialized to -1. So that means like for 20 items. So what you could do is just put -1 in here and do times 20. Okay, in this case, if I would go ahead and do print Q in this case, and I would run the code, as you can see right here, it kind of prints off everything, right? Okay, so that's pretty much it. Okay, so that's the Q over here. Okay. So now, I want to see if I'm recording audio. Yes, I am. Okay. So now that's the first part of the question. The second part is we got to make the enqueue process where we take in an integer, checks if the queue is full, and returns false if otherwise. Stores the parameter in the next position in the queue and returns true if the queue is not full. Updates the appropriate pointers and number items. So make sure that sorry. So over here, what I'm going to do is make a function enqueue. Okay. And what I would want to do is, first of all, just discuss a little bit about this. So what you want to do is take an integer as parameter, okay? So what we want to do is we want to take an integer as a parameter, and we also want to make sure that we mention that the queue head pointer, tail pointer, and number items are all global, because in the previous question, these were all global variables, okay? So just go ahead and mention that these are indeed our global variables. Okay, so takes an integer as a parameter, checks if the queue is full, and returns false if the queue is full. Okay, so first let's do that. Okay, so first check if the queue is full. To do that, if we just say that if number, sorry, number items is equal to 20, all we got to do is return false. Okay, so else, oops, sorry, what did I just do? Okay, so else, I'm just going to put it as pass right now so that there's no errors in compiling. Okay, so over here, we just want to go ahead and make sure to do a little bit of checks. First of all, if it is not full, that means what we are going to do is we are going to go ahead and, so we have 20 integers. Okay, so this is for 20. Okay, so this is for 20 integers. So keep in mind that we're talking about a circular queue in this case. So when we're talking about a circular queue, we want to go ahead and kind of circle back if our tail pointer and head pointer becomes equal. That means we've come to a certain point where those are equal. That means, well, yeah, the queue is technically full, so we can kind of go back and restart from the original position, okay? So we got to go ahead and do particularly that in order to go ahead and write the code. So the first thing is we want to go ahead and check that what is the value of head pointer and then what is the value of tail pointer, okay? So you're going to be going ahead and doing that. So in this case, what we want to do is this. Let's go back to the question. Okay, let's go back to the question. So what we want to do is that we first want to check that if these are -1. If these are -1, that means, yeah, the queue is technically uh, still empty. It's totally empty. So we want to do is if tail pointer is equal to -1, what we want to go ahead and do is we want to increment. So tail pointer is going to be plus equals 1, and head pointer is also going to be equal to 1. That means we incremented with 1, so we're setting them to 0 technically. Okay, so now if what we do is that once we've increased this, okay, once we've increased this, all we got to do is on the queue's head pointer, we go ahead and put in the value. That's it, right? So this is where we're adding the value. And we're already incrementing head and tail pointers over here, okay? Else, that means in this case, else that it's not -1. There were already some sort of data available in the queue. What we want to do is we want to first go ahead and increment, let's say, the tail pointer, or maybe the head pointer. So in this case, oh, sorry, not the head pointer, actually the tail pointer, because this is a queue, it's not a stack. Sorry for that. So we want to go ahead and increment the tail pointer by plus equals 1. Okay, we want to go ahead and increment the tail pointer by plus equals 1. And what we also want to do that if the tail pointer is equal to 20, why? We want to set the tail pointer to be equal to 0 again. Why? Because this is a circular queue, because this is a circular queue, we want to go ahead and restart. We want to go ahead and restart. Okay? So you want to go ahead and restart the entire process. Okay? We set it to 0. Okay? And then what we do is we go ahead and put in the queue data. So queue, and then we put it in tail pointer, which is going to be the value, okay? And after all of this, that means this is the process we're doing in order to go ahead and put a value. We go ahead and increment number items by 1 as well. And once it has been incremented, that means obviously we have successfully uh, uh, kind of done this particular process over here. Uh, so we've got an else over here. Then that else return false. Okay, so we are already returning false if this process takes place, and if this takes place, definitely number items. So we want to go and put it out of the queue. Okay, and then what we'll also do is return true. That should be it. Okay. So return false, that means like if it never enters, it's never returning false. Else it's definitely going to enter the queue and it returns true. Okay, if you do put it inside the else statement, I think it's still going to be yielding a correct answer because again, this will take place only if this never works. So there's actually no point in doing this inside the else, okay? Because if this happens, then we're already returning false. So just put this outside, it's not going to be affecting anything, okay? So regardless of this is outside or inside the else statement, really doesn't matter, okay? So that's going to be part 1. I mean, not part 1 actually, the Enqueue part of the program. Okay, so the main program attempts to store each of the integers 1 to 25 inclusive in the queue in ascending numerical order using Enqueue. Outputs the integer that was passed into Enqueue and successful if it was stored in the queue, or unsuccessful if it was not stored in the queue. So if we are entering 5, we just say 5 successful. If we are entering 23, we say 23 unsuccessful. Write the program code for the main the main program. Okay. Okay, so we want to do is number items of 20 in this case. Okay. Okay. So what we want to do is we want to go ahead and now write the main program. Okay. So we want to do is 1 to 25 inclusive. So right. So what we want to do is for Python, we want to do is for x, or let's just do num. It's a little bit for num in range. So it's Python, so we start from 1 and we end till 26. That means it's going to be starting from 1 and ending in 25 for Python specifically. Okay, so what we want to do is we want to check the result of what happens after we run the enqueue program. So we do enqueue and we put num through it. So if result, that means if not result, that means if result was false, we say print. So I'm going to be just doing a formatted string x over here. So we say that x, sorry, not x actually, sorry. So we say that num, and then I forgot what, oh, we had to write unsuccessful. And else that if it's result, then we do is print formatted string, and we do is num successful. Okay, so that's a pretty simple way to put it as well. Pretty easy to put it as well. All right. So yeah, that should also work. Okay, let's go back to the code, the function dequeue. Okay, so we gotta now go ahead and do the dequeue function. So yeah, the dequeue is also something that you need to keep in mind, because I've got a few questions via email that if we are already using the number items, okay, you know what, we could improve this code. Instead of writing equal to 20, what if it's greater than 20? So just let's put greater than equal to. But I think equal to does the same job because as soon as it reaches 20, you know that the queue is full. The reason why we need to use the circular queue error, not an error check, it's basically the logic of the circular queue, is because we might have a dequeue function inside the main program, like we're having right now. Like we got to go ahead and write dequeue. So what if after kind of putting in a few enqueues, you also put in a few dequeues, and then you actually don't completely fill up the space, because once you dequeue, that means you're also decrementing number items. So you technically have space, but your queue is full, so you kind of go ahead and restart. Okay, so that's one of the logics, or that's one of the ways I could explain that why we actually need to use the circular queue, even if we have a number items or some sort of a counter that's counting how many things we need to put in our queue. Okay, so if anyone's asking you that, okay, if you're putting this, then why do you need a circular queue? Because you might have a few dequeues in between. That means that proves that even if your queue's tail pointer is like all the way to the end, it can still restart and put stuff inside the queue because there were some items that were dequeued from the queue. That means the queue does have empty space in it. Okay, so that's the logic behind it. Okay, so let's do dequeue. QE, UE. I'm just going to put in a pass here just so that we can read the question and we don't arise any errors. Okay, so the function dequeue returns -1 if the queue is empty. Okay, so that's the first thing. Now, before we do anything, we also need to make sure that we go ahead and put in the global variables. Then, to check if the queue is empty, what we want to do is we want to see that if number items is equal to 0, then what we do is we return a -1. Return -1. And then we put in the else statement. I'm just going to, oops, sorry for that. I'm going to put pass over here. Okay, so the function dequeue returns -1 if the queue is empty. If the queue is not empty, the function returns the next item in the queue, updates the appropriate pointers, and updates number items. Okay, so over here, the main clue for this entire question is we got to work with head pointers instead of our tail pointers because we're dequeuing stuff. So what we got to do is that else, if we say that if our head pointer was, let's say 0, that means we have. So first we put in the value of the queue, so that the value is going to be q, and whatever the head pointer is in that time. Okay, and also we got to keep in mind that it'll always return -1 if number items is 0. That means that head pointer would always stay -1, so we wouldn't kind of come across an error. So don't worry about that. And over here, what we do is then we decrement our head pointer. Okay, sorry, increment our head pointer, not decrement, because again we're moving aside. So if the queue is like pointing towards, like, let's say we've got our, I'm just going to put it into comments that if our head pointer was, let's say, pointing towards, let's say this particular uh, position in the array. I'm just going to put dots over here. What's going to happen is now the head pointer is automatically going to move to, let's say, this position, and obviously, yeah, so obviously this part then becomes empty, so that's how the head pointer moves. Okay, so the head pointer is plus. Now again, this is a circular queue. That means if the head pointer reaches the end of the queue, which is that if we want to say that if the head pointer is turning out to be greater than or equal to 20, what we do is we change the head pointer to be equal to 0 again, okay? And obviously, once we have done that, we also want to go ahead and decrement number items from the queue. That means one item is less inside the queue. Okay, so this is for circular property, okay? And number items is equal to -1, obviously. And lastly, that we want to say that if we have emptied the entire queue. So if we say that if number items, oops, sorry for that. If number items is equal to 0, this is to check that if we have TID, I don't know if the spelling is correct, empty the entire queue. That's when we again set head pointer, sorry, to equal to -1 and tail pointer to be equal to -1. Okay. And obviously, if this entire code does run, what we want to do is we want to go ahead and return our, let's say, value over here. Okay, so that was the return value because the question, I think, states that, or does it? Okay, yeah, it does say that updates and returns the next item in the queue. Okay, the function returns the next item in the queue. Okay, okay. Yeah, so that's going to be returning whatever the next item is in the queue. Okay. So yeah, I think that's pretty much it. This is pretty much it. Okay. So yeah, now we gotta just write the program code to extend run twice and output the return value each time. Okay. So all right. So the program is the right program to extend the main program to call Dequeue twice and output the return value each time. Okay, so we want to go ahead and call DQ twice and output to each of them. Okay, so what we want to do is we want to go ahead and output the code, which I think we already have done technically, but in between that, we also want to go ahead and call DQ twice so that we could test that if the DQ is working, right? So what we want to do is write the program and output the return value each time. Okay. So what we want to do is just add this at the end of this. I think that should work since they haven't mentioned anything. So I'm just going to put val1 is DQ and also do val2 is equal to DQ. And once we do that, I also want to print val1, and I also want to do print val2. Okay, so with that being said, we should be able to run, and there you go. So as you can see, like right after 20, we are unsuccessful in terms of not being able to put them inside the array because again, it exceeds the number. If what we were to do is we were to take this, okay, we were to take this DQ once after this particular program, like just do DQ once, uh, we could have kind of added 21, 22 in between and so on and so on. Okay. All right. Let's move on to question 2. I think the name is underscore J25. Okay, so let's go ahead and do question 2 underscore J25 dot pi. Okay. Let's see, the Python file is running. Let's open a new terminal. Yeah, it's working. Okay. Yep, it's working. Just put in the terminal over here. Okay. So let's go ahead and work with question 2. So program reads data from a text file, splits the data depending on its contents, and stores it in a separate data onto different files. The text file, the data.txt, contains 72 lines of data. Okay, so we've got the text file where it contains 72 lines of data. Okay, the text file, okay. And each line of data has an integer number and a string color that is separated by a comma. For example, the first line is 10 red. The integer 10 of the string, okay, string is red. The file contains 6 different colors, okay. The function read data prompts the user to enter a file name and reads the file name from the user. opens the file and reads the data, each line of data into a 1D array. Okay, so first to note that this entire thing is initially a string, right? So it's going to be reading this entire whole piece of line tan and red into the array and returns a populated 1D array. That means the array like that is stored. So the first one's pretty easy. The function needs to work. The function needs to work for a file that contains an unknown number of lines. So make sure that in this case, we are not using a loop. Okay, this is because sometimes it's easy to miss this during exams, that you might just kind of run a loop instantly by just kind of quickly going through the question and doing the answers. But in this case, we cannot use a loop because even though we know that specifically there's 72 lines of data in the file, what we want to go ahead and do is read uh, until it's like the end of the file. Okay, so what we want to do is, let's go and go back to the question. So we want to do is def read file. I'm going to name it as it says. The text file, okay. The function read data. So it's not taking any parameters. So first we want to do is f underscore name. That's the file name, and I'm going to be taking input from the user. So input, sorry for the star, enter the file name. Okay, so now what we want to do is file equal to, we want to do is open, and you could also do it in one line, that's also fine. So we want to do is f name, and we want to do it for read, right? So that's what we want to go ahead and do. All right, so in this particular case, we also want to go ahead and make an array. So we want to do is f data, so that's the particular file data. So this is where it's going to be storing the info. Okay, so what we're going to do is open file for. So in this particular case, what we want to do is we also want to go ahead and do a error check. So we want to do is try, and then I'm going to put pass over here. And then in this next one, except we want to do is file not found error. That means we couldn't find the file. Print, we want to say is incorrect file name. Okay, so you could just put in any error message. I don't think that really matters. So over here, so what I just do is cut this line and put it in here. Oops, sorry. Want to do this. Okay. All right, so we want to go and open the file, and then we want to do is f. I want to do is f line. That means we're going to be reading the line. So we want to do is file dot read line dot strip. So the strip function does what is it omits this new, because over here, basically you've got a new line character, like you got a new line character like this. Okay, so what the strip function does is it removes this new line character. Okay, you could particularly put in something else into this kind of strip line area, or what you could do is just kind of not do it. Either ways, it's also fine. Okay, so now in f data, so what we want to do is f underscore data dot append, and over here, now the reason we're using append is because we don't know exactly what the count number is going to be, so we got to go ahead and do append. uh, Append, and we want to do is f line. Okay, you could also add a secondary line that all right, like kind of keep doing it, so we kind of need to do a loop. So what we want to do is, for, let's say we've got f line right over here, right? So we got like f line. So what we can do technically is, while f underscore line is not equals anything, we kind of go ahead and do is let's say f underscore data dot append, and then we go ahead and put in f line. And over here, we kind of reread the line just here once again. That should be it. And obviously, once it reaches the end of the file, it's like empty, so it's not going to do it again. And finally, we want to do is file dot close. That means close the file. Okay. And yeah, that should be it. That should be it to do the code. And I don't think there's any compilation errors. So we want to do is Python .py. So there wasn't any compilation error. The code was compiled perfectly. Okay. Okay. Good. All right. So let's go ahead and move on to the next question. The procedure split data takes the 1D array string array as parameter with the identifier data array. Okay, so they've given you so def split data, and we take data array. Okay, array as parameter. I wish I kept recording. With the identifier data array, the procedure declares 6 1D arrays, one array for each color that appears in the file. The procedure accesses each string in data array. The data, okay, the data in each string is split into the integer and the color. The integer is stored in the array that matches the color. Okay. Interesting. For example, the first string in data is 10 and the color is red. So the integer 10 is stored in the color red. Write program for split data. Okay, a lot of work to do. Okay, so basically what we want to go ahead and do is we want to go ahead and take in this data. So in the first question, returns the populated 1D array, which I forgot to do. So what we want to do is over here, just click on return f underscore data. That's it. Just return this entire array. That should be it. So you want to go ahead and just take f data and put it into data array. Okay. Okay. So in the pass function, what we're going to do is prompt the So what we want to first do is go ahead and declare or create 6 arrays. Okay. So in this case, what I want to do is So how many colors do we have? So we've got red. So for red, let's do 1. Then we've got green. Let's do 1 for that. Then you've got blue. Let's do 1 for that. Then you've got orange. Let's go ahead and do for that. Yellow. Let's go ahead and do for that. Pink. Let's go ahead and do 1 for that. Okay, so the function read data prompts the user. Okay. Sorry. The procedure accesses each. Okay. So now what we got to do is for I in range, so length of data array. So we got to access every one of them. Okay. So what we want to do is take the string, or let's just say the array data is going to be data array I. Okay, so that's going to be the first element that we take. Now, what I want to do is also go ahead and kind of keep splitting. Okay, so over here is an easier way to do it, but what we want to do is also go ahead and make it a little bit, what do you call it? Easy? Let's just say easy. Okay. Um, so what we want to go ahead and do is, let's say that we want to go ahead and do it something like this. Okay, so what we want to go ahead and do is break the array in the area where, or break the data where we have got the comma. Okay, now the easy thing that they have done for us is that they haven't used any spaces. So what we want to go and do is we just want to use, let's say, that array. So let's just do line or capital L, anything works. So what we want to do is we want to go ahead and split, okay, the data uh, on the area where there is the line. Okay, so what the Python function split does is it creates an array and makes a split in the uh, area where the comma is or the particular character is. Uh, so basically, what we want to do is we want to go ahead and split the area specifically in the place where there is the comma, right? So what the split function specifically will be doing is it divides the string into a set of, kind of substrings. So, or, separate strings like into an array. So what basically Python is doing, like let's see if I take array dot split, and in the split, all I need to do is all I gotta do is just put this comma in. So what basically uh, the Python function is technically doing is it's creating an area like this. So basically, if you've got 10 comma, let's say red in one element, it's basically turning this into two different arrays. So it's turning one into 10 and another element into, let's say, red, and it's splitting the file exactly where the comma was. So for example, if I said that the split would be, let's say, R, it would have split the file into something like 10, and then the comma would be over here, and then it would kind of go ahead and remove the red over here. Okay, so basically, uh, it kind of does that. Okay, so basically, the split function works in different ways. You could use a comma over here, that's fine. And what you could also do is put in a max value over here. By the max value, what we mean by that is basically, uh, let's say if you put 5, that means it's only going to be separating up till 5 characters from the split section. So basically 1, 2, 3, 4, 5. So in this case, let's say it was reddest or something like that, or some sort of words. It would have only split till red. So basically we would have gotten, sorry, not ed, we would have gotten red, something like this, okay? So basically what's going to be happening is we're going to be having, okay, so I'm just going to erase all of this. So basically we're going to be having uh, two values. One is going to be red and the other value is just going to be 10, which is split between the two. And the split character is like omitted over here, okay? So basically, uh, that part would be the what do you call it, basically that particular part would be considered or would be particularly split. Okay, so basically you omit that part. So in this case, the comma would be omitted. So I'm going to be moving this 5 out because we don't want any maximum character separation or something like that. Only what we want to do is we want to take one element and just split it over there. Okay, so now we put in the condition that if line 1, why is it 1? Because this value right here is this is 0 and this is 1. So if line 1 is equal to red, then what we do is red dot append, and in the append area we do line dot line, and we put in the 0. That's it. Okay, so you got to do similar things. So we got to do else if line 1 is equal to, let's say, green, what we want to do is just do is red, sorry, in this case, green dot append, and then we put line 0. That means the number, okay? Similarly, we do is else if we've got, let's say, blue. Now, you could have used a string concatenation method if you didn't know that the split function existed in Python during the exam, but it is better to know shortcuts. But again, yes, it is possible that you take in empty string each time inside the loop and keep on concatenating. So once you get to the comma, what you do is you skip that comma and then put in the color in a different area, and you could match that. That also works, but that becomes much more lengthy. But I could go ahead and show you guys a easier way, or just show you that lengthy method as well. So let's just finish this method first. So if what we do is sorry, so if line 1 is equivalent to blue, then we could do is blue dot append, and over here what we would do is put line 0. Okay, so we would put it in blue. Then we've got orange, so what we want to do is else if line 1 is equal to orange. It's all in smaller cases, so that should be it. So we want to do is orange dot append, and we want to do is line 0. Else if we've got yellow, so we want to do is line 1 equals to yellow. We do yellow dot append line 0. So you're done with it. And finally, else if line 1 is equal to pink, we append pink dot append line 0. Right, so that should be pretty much it. Okay. Yeah. Also, one more thing, right? Okay. Yeah. Yep. So, okay. That should do it. That should do it. Okay. So let's just check if so. Yeah, everything seems to be compiling. We didn't come across any error. Let's see if okay. There we go. Yeah. So okay. No errors. No errors. Okay. Okay. So that ends the split data part. Now, if you would want to, okay, so let's just for the sake of doing it, let's just say that you wanted to do it the harder way. So how would you do it? So in this case, what we would do is we would take array dat. Okay, so we take data array 1. Okay, and we do. I would have given, let's say, number a string, and we would do color as another string. So for, then let's say we would say for x in range uh, array dat. Okay, so in this case, what we would do is that if let's say x, so for x in range of the array dat, and then it's going to be for the length of array dat, right? So in this particular case, what we would do is if let's say array dat x is equivalent to a comma, okay. Uh, oh, it's not equivalent to a comma. What we would do is we would do number dot append. Oh, sorry, not number dot append. Sorry. So number would be number plus array dot x. Okay, array dot x. So that's kind of adding it. Okay, once and we'll also put in a flag. So let's say we've got flag is initially equal to false. Okay, so if it is not equal to, okay, if it is not equal to, so that's when we do it. Okay, so and then our flag is still false, right? So what we could do over here is we keep putting, we're concatenating into the number. Okay, we're concatenating the number, and notice the numbers are only 2 digits or a single digit. So this would be this would be a variable, or this would vary. So in this case, what we want to do is once we have reached the comma, okay, uh, so what we want to do is we want to take this into another condition that if is equal to this, what we would do is we're going to change flag to true. And we want to do is if flag, that means if flag is true, then we would start to concatenate into color. So color would be color plus dat array underscore dat, that's going to be, okay, so now the problem would arise kind of over here, right? So what would be the problem? The problem is taking in the color, okay? So if it is true, what we want to go ahead and do is in the color, we would like to start taking it after that array. So we gotta go to this, go to x plus 1. So the problem that is, or that might end up arising, is this x plus 1 that's going to be giving us an error. Okay, so this would be to extract the text. This is for extracting the text manually. Okay, but again, the problem that might arise through this particular piece of code is x plus 1 might just give us a length error. Okay, so that would be the issue over here. So that might turn into an issue. But again, this could be the particular code that would allow us to go ahead and give us the array in the dot position over here. Okay, so that's kind of going to be it. Oops, sorry, I caught a receive a call. I'll just pause. Sorry for that. So this could potentially give us an error. Now that could be fixed. That could be fixed. That if array.x specifically is a comma, what we could do is Python is based on C programming language. So what we could do is we could just take the flag and make it true and write something called continue. Okay, so continue skips one iteration and just goes to the next. So that's coming from the C programming language. And just change this that if, so we just do is if flag, that means that we have also if, so we want to do is if not flag. That means we're still looking for numbers. So basically in this case that we want to do is we want to put it in numbers. So number plus array dash dat x. And we want to do is if flag, that means we have already reached the color part. So what we want to do is color is equal to color plus array underscore dat, and then we put in an x over here. Okay, so this could be another manual way of extracting the text if during an examination you do not know the split function. So again, this is a very specific use case. Again, obviously the split function is going to be much more efficient, but again, during the exam, you never know. If you forget the split function, how it worked, this could be a manual method that you might have to come up with. So that's going to be an issue. Okay, so let's go and move on to the next part. The procedure store data takes two parameters, the one the array data to store and a file name. Opens a text file with the file name that is passed as the parameter, appends each item. Okay, to a new line of the text file, uses exception handling. So obviously we got to go ahead and do that. Okay, and then obviously we got to test it for the next one. Okay, so let's go ahead and move on. So the procedure is stored data. So what we are going to do is we just want to go ahead. So this is going to be just a comment. So let's say so def store data. I'm going to be keeping this comment over here just so that when you're accessing the code from a GitHub, you could look at both the methods or try them out if you want to. Okay, so the procedure store data takes two parameters, one the array, so data to store, uh, opens and a file name. Okay, so let's just go ahead and call it file name. So, okay, so opens a text file with the file name. So what we want to do is just make a file, then we want to call open file name, and we want to do is we want to write to that file, right? Okay, and passes parameter, appends each item to data store in the new line of the text file, appends each item to the data. Okay, each of the systems has a blank text file, the number will be stored. The procedure split data needs amending to, okay, split. Okay. Okay. So what we could do over here, since we have questioning to do. So in this case, what we want to do is we want to open it, and obviously we want to, okay, so we would have used write in this case, but the problem is we don't know when the user of the program is going to be calling for which file. So if we use write, what's going to happen is it's going to be going ahead and replacing the contents of the file every single time. So instead of using write, because it's not going to be serial that, okay, it's going to be using let's just say green, red, pink, because again, since we need to amend split data, that means we somehow have to use store data into split data. So in this case, what we have to go ahead and do is use the amend function. I mean, sorry, the amend operator, because if we use write, it's going to be going kind of overriding every single time. Okay. So with that being said, appends each, so it even says in the question appends, so you could use that as a clue as well. So appends each item to data to store to a new line of the text file. Okay, cool. So for uh, things, let's just call it things in data to store, or contents, whatever, just give it a name, okay? So all you want to do, or all you want to go ahead and do is we want to go ahead and write to that file. So basically for Python, that's going to be write, and then over here, that's basically going to be things in this case, right? And if it says that we have to do it in a new line. That means we have to write a new line as well. So in Python, how do you write a new line? It's simply you put a double underscore and then a forward slash n. Okay, again, it's coming from the C programming language. So you just go ahead and put that. And obviously, this is going to be file dot close. Now, obviously, we got to go ahead and use exception handling. So what we had to do, which I forgot to do, is we want to go ahead and do the exception handling right here. So what we want to do is put try. Now, once we put try, obviously, we got to go ahead and do the indentation right here, right here. Okay. And over here, except what we want to do is file not found error. That means print. We can just put in any message we want. I'm just going to put file was not found. That's it. Okay, so that's going to be doing it. So I'm going to go ahead and take store data, cut it, and put it on top of split data because I think we got to use this in split data. So basically that's going to be it. So what we want to do is in each of the 6 colors has a blank text file, so it's already pre-made for you. So over here, the procedure split data needs amending to call store data 6 times. Okay, so it's going to call it, okay, amending to call, okay, 6 times with each of the 6 color arrays. Uh, oh, okay, so they've mentioned it, it's like 6 times. So what, okay, so you probably didn't need to do this. Okay, I guess this way is also fine, like every time you're going to be doing it for kind of. so data to store, file name for things, and okay, so for things and data to store. Okay, that's totally fine, right? So what we want to go ahead and do is we want to just go ahead and call it. Uh, so the thing is, procedure split data. We've got store data. So will be called 6 times with each of the 6 color areas, and the name of the text file that is okay. Okay. So the now what we need to do is we need to account for this particular thing that we just used here, okay? So technically these are local to your program, right? So these are going to be local arrays in split data, right? So okay, so then I'm going to go ahead and just cut this and put it back where it was, since we have to use these, okay? So in this case, what we want to do is we want to go ahead and do store data 6 times. So first, I'm going to be doing it with red, okay? And since I'm again doing it with the red, what I'm going to be going ahead and doing is for every single file. So obviously for red, it's going to be red, yeah, .txt, it's in capital, so I got to keep that in mind. Right, so we've got red. Now, the problem that's going to be arising is you can already see that the red is kind of marked. And if I go ahead and hover over this, uh, it says that the red is not declared. Okay, so the red is not declared. That's what I'm sorry. This is in Japanese. I forgot to change my language, but it says that red isn't declared. Red ga teiki sarete imasen. So basically, what we want to go ahead and do is go ahead and work on split data, because look at the question. It says the previous split data needs amending to call stored data 6 times. Okay, so we need to go ahead call store data, which is either going to be inside, kind of this red over here. Okay, I'm sorry, particularly over here. So what we would want to do is actually follow what I did right before it. That is, place it on top. Because otherwise, if you don't have it on top, this function won't know where to call it from. But since it's Python, it actually works on any position, so that wouldn't mind. So I'm going to cut this, and what we want to go ahead and do is get out of the loop. Okay, get out of the loop, and just call this a bunch of times. So you're going to do is green, and over here we want to do is green. Then we have blue, and we want to do is we want to go ahead and do blue. After blue we have orange. So what we want to do is just go ahead orange. Then we've got a yellow. So what we're going to do is do yellow. And then finally, what we want to do is pink. Pink. Okay, so since it's already being called inside split data, the only thing we need to do is now call up read. Oh, this name should have been read data. So over here, this is going to be read data. And if I'm not wrong, we don't have any parameters. So we just do is we call read data uh, and return f data. So what we want to do is color, or what we want to do is let's just call it main array. That means this is the one that read data is going to spit out. Okay. Then we want to do is when call split data, and the data that's going to be in is going to be called main array, right? Because that's what is being split out or being spit out. So for Python question 2 underscore j25 dot pi. Let's see. Okay, so we can enter the file name. What just happened? Oh, sorry for that. So obviously the file name is going to be the data.txt. Okay, it does run, but it wasn't showing any output. That's interesting. Okay, there you go. There you go. So yeah, the program did run correctly. Now, I want to go back and see that, take a screenshot of the outputs and a screenshot of the content of the outputs and a screenshot showing the content of the file that stores the red numbers. So for the output, were we supposed to do any outputs? Let's have a look. Did I miss something in the appends? Okay, I think the function needs to work for a number. Yeah, so I don't think we need, like, we just show this. Oh, okay, this is going to be the output, obviously. And for the red ones, so we go to the red ones and take a screenshot of this during the examination. So that's pretty much it. So yeah, that's pretty much it. That's pretty much going to be it. So array that. Uh, So what I want you to do is at home, just use this particular code instead of this 2 lines of code. Okay? It might look lengthy, but this is when you kind of forget like how the split function worked. Okay? So just one more question left. So let's go ahead and do that. So we got question 3 underscore j25 dot pi. Okay. I'm gonna erase my terminal and then just put up a new terminal right here. Okay. So let's go ahead and work with the following question. So the next one is an object-oriented programming question with a binary tree. A program stores data in a binary tree that is designed using object-oriented programming. The tree stores data in ascending numerical order. For example, this. So it already tells you what to do. So the class node. So we got to go ahead and do an object-oriented programming. So we already make the class node. Okay, so in the class in itself, what we want to do is we want to do the initializes node data to its parameter values, initializes left node and right node. So, so what we want to do is do node p, left node p, and we've got right node p. So let's just do the constructor first. Okay. So in this case, write program code to declare the class node and its constructors, which we have already just done. And obviously, if you're using Python, just do it with comments. Now, again, these are all private. So hashtag you could just do is private, or you could just write something that private node, or you could just do like private colon node, left node, right node. Okay, you could just do that for your exam, and that should be fine. Okay. Now it says write program code for the 3 get methods. So obviously get left, get right, get data. So just let's go and do that. So we've got def get left, def right, sorry, get right self, think it was, yeah, it was get data. I think it was, oh, it was node data. So we just do is node data. Just change the name. Okay, just default the question. Okay, cool. So now we've done the set method. Takes an object of type node as parameter. The method stores a parameter of attribute in the left node. Okay, so uh, fairly easy, fairly simple. So what we're going to do is def. We have set left, right? So again, this is going to be particularly for setting to the left node. So all we want to do is we're going to take a parameter. Let's just call it val. So over here, what we want to do is self dot. Okay, instead of doing yeah, we're going to do is self dot left node is going to be equal to val, and that's pretty much it. Similarly, def set right. Again, we take a val as parameter, any type of value. Self right node is going to be equal to the value. And yeah, those two lines of code should be perfect. So okay, now we got to make the binary tree. So in this case, node 1 with data 10, node 2 with data 20. So again, just follow the examples that's kind of right over here. So node 1 with the data 10. So do we have an example? Oh, okay, we don't have an example. So node 1 with data 10, with data 20, data 30. Now, one thing that means I've missed is like initialize left node and like right node with a null value. So I kind of didn't notice that. So obviously we take these out and just put in two negative ones. That's it. Or you could choose any other null value like 0 or something like that. It's totally up to you which one you or how would you choose it. Okay, so you could do anything with that. Now in Python, you could either do -1, but I think a better method is just use none. Okay, that's like basically a null object. Okay, none, that's it. But you could also do -1. That's totally fine. It really depends on how you write your code. I believe that the mark scheme also says that to use none, but you could definitely use -1. That's also fine. That should work. Okay. So with that being said, so we want to do is node 1 is equal to node, and my value is going to be 10. Okay, so that's pretty much going to be it, and we can just kind of keep doing that. Okay, so I'll just copy this. That's going to make my work a lot easier. So 2, let's take a look at the value. The value is 20. 3, let's take a look at the value. The value was 5. Node is, oh sorry, node 4 is equal to, the value is 15. Node 5, the value was 7. Okay, so there you go. Just make the nodes, 5 objects of type nodes, and we're done with it. So the class tree stores the tree. Okay, so we've got to make the tree now. So this was the class of node. I'm just going to collapse this. It's going to make it easier. So let's make a class tree. I don't think there's any inheritance. Okay. Stores the roots. Constructor initializes first node to its parameter value. Okay, so we were here. So this is going to be the first node parameter. So I'm just going to write it as first node p. That's the parameter. And we want to do is a private. Now you could do it as public, but Cambridge expects you to do it for private. All of them should be private. So just do them as private. So we got to make tree and its constructor. Fairly easy, fairly simple. I think it's pretty much 3 marks. I think the harder part is going to be get root node and insert, because that's going to be return to the node stored in first node. Okay, initializes first node. Okay, to its parameter value. Okay, so basically get root node. So basically that's going to be whatever is like stored in the first node. So basically write program code for get root node. So it's pretty self-explanatory. So we just do is we write the code for get root node. And we already know that what first node is, because that's the first thing we're storing. So all you need to do is just click on return self first node. That's it. That should be it, because the purpose of the root is to return the node stored in first node. So that's pretty self-explanatory. Okay, oh wow, a lot of it's left. So the next one, it says the method insert takes a node as a parameter and then searches the tree to find the position to insert the new node by. Uh, Now, obviously, this is going to be a much more linear method, so we are going to be going ahead and doing this the hard way. Okay, so they kind of explain you what to do instead of I think May June 2024, where they just told you to write the code for insert and they never explained what to do. So that I think was a much more difficult question. So check whether the node's data is less than or greater than the root node's data. So obviously that means moving to the left node if the data is less than, moving to the left node if the data is less than, moving to the right, repeat until the final position is found. So we kind of know how a binary tree works. That means what we're going to be doing is we're going to be checking that we like if there is a root node, then you see if it's greater than. If it's greater than, then we move to the right side. That means we use set right. If it's less than, we use set left. If this is 0 or none, that means we go ahead and put it in the basically node value, or the root node or first node. Okay, so what we do is take a node and search the tree. So checking whether the node data is less than or greater than the root node data. So if the root node is not present, that means we don't do it. Okay, so first of all, so let's do def insert. What we want to do is self, and that's going to be the value that it's taking in, right? So first, let's put, like, this is going to be our current node. So we just make up a node type parameter. So we just do this node and put in val. Okay, so this is like we have made a temporary node for it. Okay, so we want to first see that if it is inserted or not. Okay, so if it's inserted into, so current, that's going to be the current, and then we've got the node over here. Okay, now uh, before we put it in any node, like making that current node, what we want to do is we want to see that if it is the root or not. So first, what we want to do is basically check what the current node is. So basically, first node. So this is going to be our current. If it's empty, that's when we're going to be putting the val in first node. Okay, and we want to say that inserted is false. So while inserted, okay, that means we're assuming, so, oh sorry, this is going to be true since we're doing, you could do it the other way as well, that also works, it's up to you. So if, so if current dot, okay, so this current right here is going to be going ahead in the format of a node, obviously, and this value right here is going to be of type node, right? So that's where we're using current get node. So we're going to be using this current get node is less than. Okay, so if it is less than, so if the value, sorry, so we want to first go and check the value. So if the value is less than my current, okay, that means my root value. If it is less than, so what we want to do is current node. So this current right here is from this right over here. So again, it's also in the format of node. So we want to do is current data. If that is the case, okay, if that is the case, we check that if of So we check that if current get left is basically equivalent to none. That means if the left one is empty. If it is not, then voila. Okay. So if it is not empty, then we do is current set left, and what we do is we just put in val right over there. Okay, we put in the value. Else we have got to check that if it is less than or greater than, and I think insert. Okay, so this should be it, but just to make sure that the thing's working, I'm going to be putting a return true in here. You don't need to do that though. I don't think that is necessary. Okay, so what we want to do is now the problem arises that we don't know if it's greater than or like if it's none or not, right? So in this case, what we want to do is we want to change the current pointer to current. So current is going to be basically current get left. Okay. So basically, what we are just trying to do over here is if I go back to the question, we first go ahead and check if it is less than. If it is less than, we move on to the left. And if it is not empty, then then what we do is we just take this. The current one is going to be this one's left side. So we just replace the value with 20. So in this case, I don't know if Chrome has a content annotate. All right, so I don't have my graphics tablet. So let's just assume that, okay, so currently the value is 30, okay? And the input value is 20. So we know that 20 is less than 30. So what's going to happen is current has 30 and it has got 20. All right, sorry, let's just say that this is 15, okay? So we want to go ahead and do is, let's say this is 15. It's got 20 and it's got 45. So since it is less than, what it's going to do is current is going to take this and get left, and it's going to be going ahead and moving its pointer to this. So therefore, the new current value is going to change to 20. And the process is going to repeat. It's going to be checking that if 15 is less than 20. Yes. So now we've got 20, and then we've got 1, and we've got 21. Right? So it's going to go ahead and move the pointer to this by using get left, right? And then it's going to be checking that is 15 less than 1. The answer is no. So what's going to happen is we have 1, and on the right side it's blank, it's null. So basically the new tree is going to be 1, then it's going to be 15. So that's going to be it. That's going to be the task of our code. Okay, I hope my annotation was pretty good because I'm not using my graphics tablet right now. Anyways, so going back to the actual code itself, so what we want to do is current get left. Okay, so then we go ahead and do a else once again. So else one again, so that means it's not going to go to the left, so we don't need to do the check anymore. So what we just do is on the else section, we just do is we do so we're going to go ahead and just do current is none. All we got to do is current dot set right to the value. That's pretty much it. And if that's not the case, obviously, then we got to go ahead and update current again. So current is going to be current dot get Right. So that's going to be it pretty much. Okay, and obviously after that is done, we're just going to go ahead and return true. So using this is going to be ending the insert, program, because again, we don't want to keep inserting once we have already inserted in some place. Okay, so that's just going to be an indicator to end the program. Okay, so with that being said, let's go ahead and move on to the next question, which says the recursive procedure output in order outputs the stored entry in ascending numerical order. Okay, so the procedure takes a node object as parameter, check if the left node, if there is a left node, the function calls itself with the left node. Outputs. So basically, this is an in order traversal. Okay, so in order traversals are, I don't know if they're explicitly mentioned in the syllabus that you gotta go and explicitly learn in order traversal to solve the program. But if you do need to, then what's going to be happening is we got to do an in order traversal in this case. So what we want to do is, what we're just going to do is just go ahead and do the recursive output in order. So in order is not part of this. So what we're going to do is def. So it's separate. Okay. Outputs the data stored in the binary tree in ascending numerical order. Takes the node object as parameter. Takes a node object. So okay, I'm just gonna call this node. Okay, let's just call this node. So what we do is that if node get left is not none, because what we want to do is we don't want to go ahead and we want to go. So it kind of explains it to you. So if it is null, check if it's null or not. And if it is not null, then we gotta go ahead and call the program itself with the left node. So in this case, let's say it's not null, what we do is we do the in order traversal and call output node again, but this time with the left node. So what we want to do is node dot get left, right? So we just want to go ahead and just call it again. Similarly, so it's an in order traversal, so basically we just go ahead and print the root node, so node get data. So get data is from this right here. We just returns a node data. And we also want to say that if, because it's in order traversal, because once we call it, we print it. If it's in order, it's in the middle. If it's post order, it's at the end. And if it's pre-order, it's going to be at the top. So this is like the easiest way to remember. In order traversal, print statement in the middle, or the return statement in the middle. Post order, the return statement is at the end, and pre-order, the statement is going to be at the right. Sorry, if it's a pre-order, it's going to be at the top, like the return statement, the print statement. If it's post-order, it's going to be at the bottom or at the very end of the program. That's like the easiest way to remember it if you want to memorize it just for the sake of the exam. But I'm going to explain to you what happens in just a bit with some annotations. So if it is like if it's not null, it has a right node, then we got to call the program again with the right node value. So get right. So what's happening is basically if we kind of go back to the diagram that they've given us, it's pretty helpful in the exam that if you can draw a diagram. So in this case, we first go ahead and take a look at this. So we take a node value, which is 30, okay? And we check that if it does have, kind of a value or not. Can I move this? Oh my God, no. No, I don't think we can move this. So we check if it has a right node or not. If it's not none, which is true, we go ahead and call the function again with 20. Okay, great. And then once we call it again, we go ahead and call the function again. Okay, because it has got a left one. Fine, so we're going to go to the left side once again. In this case, what's going to happen is, do we have a 1? The answer is yes. Is it none? The answer is yes, it is none. So what's going to happen is it's going to be outputting 1 in this case. Okay, so it's outputting 1. After that is the case, we have to do recursive backtracking. So what's going to happen is it's going to go back to 20, and then it's going to come back here. So you might be asking that again, wait a minute, that's not ascending order. But notice that if we come to the program itself, uh, in ascending numerical order of the binary tree. So in this particular case, what's going to be happening is that we go back to 20 because we have to backtrack, and backtrack code gives us the print statement. Okay, cool. So we go to and we print 20. Cool, comma. And then since we're backtracking, we have to now check because we have completed this line of code. So now you gotta go, sorry, now we gotta go to this line of code. So we go back to this line and then yes, we have 21. Do we have anything else on the right? No, we don't. So we output 21. We backtrack. We have already done 20. Great, so we backtrack and then we print 30. Now, since we are backtracking, now we gotta go ahead and enter this particular line of code. So we enter the right side. Okay, we come to the right side. Is there a left side to it? Because again, once we go to the right, we got to go ahead and restart the program. So is there a right side to it? Yes, there is. So we move to, is there a left side to it? Why? Because again, we're restarting the program. So on the left side, yes, we have a left side to it. So again, we're first going to go here. Is it null? Yes, it is null. So we print 33. Then we go back, backtrack, print this because we have the print statement, and then finally go to this one's right side. Do we have a right or a left side over here? We don't, so it's null totally. So we just print 63. So notice that this was printed in ascending numerical order. So that's the work of in-order traversal. For post order, it's just going to go ahead and print the left side, then the right side, then the left side, then the right side. And sorry, that's for pre-order. And for post order, it's going to print the right side, then the top root, and then the left side. So it's kind of goes the opposite way. So that's the only difference between the three traversals. So make sure you kind of memorize the code if you want to. That's like the easy way to kind of get it, or do it the difficult way. That's totally up to you. Okay, again, it's if you want to understand it, that's totally up to you, or if you just want to pass the exam, that's it. Okay, so with that being said, we finally need to do is write program code to extend the main program. So it's going to be creating an object of type tree with data as its first node. So basically 10 is going to be the first node. Okay, and then what we're going to do is insert the value of 20, 15, 7 into the tree order given. So all we got to do is, in this case, what we just want to do is, let's say we make, let's just call it binary tree. So in this case, for the binary tree, so we do is tree, so the first node, so tree in this case, that's going to be starting with 10. Okay, so in this case, binary tree dot insert. So why are we doing insert over here? Because we're using this particular value itself. So we do insert, and if the code is right, if it's functioning, we do is 30. Because in the tree we already have, because again, this value is going to take the current and insert true. So this value that it's taking, it's already of type tree, and it's going to get node and then get current data. So what does get node do? It automatically, oh wait, get, I'm missing get node here. Shouldn't it be get root node? I think, yeah, I think I messed it up a little. This should be get data, not. So we've got get root node over here. Then what are we using root node for? So that's going to get root node. Okay, let's keep writing the code. So we insert the next data into a binary tree, which is going to be 5. Binary tree, insert the next data is going to be 15. And lastly, binary tree dot insert, that's going to be a 7. Call output root node with the tree. Oh, okay, so the tree's root node as parameter. Okay. So binary tree dot, oh, okay, so all we just do is we just do output in order, and we take in binary tree dot get root node. That's it. So the root node is going to be the first node itself, which is going to be 10. Okay, so I think Python question 2 underscore g 25.py. Okay, so we run into our first error of this entire video, I guess. The int object has no attribute get data, so it's line 41. Uh, so what we want to do is we want to just go ahead and take in the node. Oh, okay. So if you want to use get data, this has to be of type node. Oh my god. How could I forget this? Okay. So this basically this thing right here is a node. So in this case, we particularly need to do like node, 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 right? Okay, so now okay. There you go. It automatically updates it and outputs it in ascending order. Okay. Sorry for all these errors, I mean, but yeah, that's it. That's the answer. That's the final answer. That's the final code. Okay, so hopefully I could explain to you the hard part about binary trees and inserting stuff into the binary trees, but I think it's a pretty easy way to do it. Like we just make kind of temporary dummy variable and start comparing. Like if it's less than, that means obviously it has to go to the left one. And obviously, right here is the self dot first node. So we know what the first node is. So right here, binary tree. So with this tree node, that means we already are inputting what the first node actually is. Okay, so that's like the first node. So we already know what that is. So we start off with the first node, uh, and then we could also like use yeah, and then obviously we just kind of do it, right? So that's pretty much it. Uh, Return true inserted, which is kind of true, obviously, and yeah, that's pretty much it. So yeah, that should work. Uh, so inserted is gonna be yeah. Now, particularly, you don't need this variable. Let's just omit this. Okay, so I'm just gonna do is insert it and just do while true. Right? Because we just need a loop until the return statement is like until we're done. So we could just go ahead and use this. I think that should also yep, that also works. So we don't actually need to use the inserted variable. I think in the mark scheme they're using something similar, like a dummy variable. I think they're using inserted as well. But you actually don't need to use it. You could just use while true because we just need to loop until we kind of come to the return statement because like we have already inserted it. So we're already checking it. So you really don't need to do that. All right. So it just checks that if this is available, it just compares the values, and if it is like, yeah, it's like 30, okay, there is a value, it is less than, okay, we then move our counter to 20. Then we check if it's less than, yeah, it is less than, so we move our counter to 1. Yeah, it is greater than, so we move our counter to the left. And there's no value, it's already none, so we just insert it over there, okay? So with that being said, that ends our video. I'll be putting in this code in my GitHub, so if you want to download it and check it and practice on your own, good luck with that, and I'll see you in the next video.